A complete blockchain framework built on top of HackWasm. So it will compete with things like Cosmos SDK, with Substrate, with OP Stack, Arbitrum 9 for start and that kind of thing. So the idea is you can build your entire HackWasm. You write a simple configuration file to hook up those contracts together, and then you just run that configuration file, and you get an app chain or app rollup, whichever you choose. So that is the big thing, at least 1 year away. And the other two are simply spin-offs from that big thing. So ICS-999, for example, our topic for today is the IBC protocol I implemented for CW SDK. While abstract account module is the account model of CW SDK ported to Cosmos SDK so that you guys can use it today, right? So it is a account abstraction / smart contract wallet framework for any AwesomWasm enabled chain. I'm going to talk about it at OsmoCon next week, so check it out if you're interested. All right, so what is ICS-999? It is an all-in-one IBC application layer protocol. So currently we have a number of IBC protocols. They all have an ICS number. ICS stands for interchain standard. For a few examples, we have ICS-20, which is the standard for fungible token transfer. We have ICS-27 interchain account, which allows an account to execute actions on another chain. And of course, we have ICS-31, which is cross-chain queries. ICS-999 is an all-in-one protocol with the capabilities of all the aforementioned 3 protocols. And it is implemented entirely in AwesomWasm. So now the question is why do this? Why don't we just use those 3, right? And the answer is they are just not very good. And I'm going to use a use case to explain why they are not very good. And the use case is Stripe. So we know Stripe is a liquid staking protocol. The way you use it is you first send tokens, let's say Osmo in this case, to Stripe chain. And then you tell Stripe chain, hey, I want to stake these Osmo tokens. So what Stripe chain is going to do next is they want to IBC transfer those Osmo to osmosis and delegate them to a validator or validators. Right? So this is a pretty basic task, right? Send and delegate, just 2 actions. So unfortunately, if you want to implement this with existing protocols, I think you're going to have a very difficult time doing it. And I summarized 8 reasons why this is going to be difficult for you. Reason number 1, these 2 actions need to be done over 2 IBC channels over 2 packets. So if you guys don't already know, channel is basically a pathway that messages, data packets go through between chains. Right? So we already know ICS-20 is the fungible token channel, and ICS-27 is the interchain account channel for the cross-chain execution of actions. So they both have their own channels, and you have to send 1 packet on the ICS-20 channel to do the first thing, token transfer, and then a second packet on the interchain account channel to do the delegation. So that's the first problem. You have to do it over 2 packets instead of 1. So you might say, oh, it's fine, not a big deal. I'll just send two packets on my source chain, which is Stripe in our case. No biggie, right? Well, it is a problem if you consider this together with the following 2 problems. Problem number 1, there's no ordering between 2 channels. So if you send 2 packets on the same channel, you can order it if you use a special channel type called the order channel. But if you have 2 packets on 2 separate channels, you cannot enforce an ordering. You cannot say, I must have this packet delivered first and that packet delivered next. You cannot do this ordering. But unfortunately, in our case, we need the token transfer to be delivered first. We cannot say token transfer wait, we do the delegation first. That doesn't work. We're gonna have to attempt to delegate without even having the tokens. That's gonna fail. Right? So we need ordering, but IBC protocol doesn't provide us with a way to order 2 packets on 2 different channels. You might also say, I can just do this. I'm going to send the token transfer packet now, and then I'm going to wait. And maybe after 1 minute, I will send the second packet. Well, that doesn't work either. Maybe some IBC relayers just want to play with you. They're going to withhold that token transfer packet and just do the second packet. You cannot control that. So how do we do that instead? Well, one possible solution is to use the callback pattern. So the way you see those steps 1, 2, 3, right? So we first send the first packet. We don't send the second packet yet. We wait for the response from packet 1, and only after we see the response and we know packet 1 has been successfully delivered, only then we send the second packet. So if you know JavaScript, I have a code snippet here. So we do send packet 1, that's a function that returns a promise, and then you use the then keyword to chain an action after that promise. So you see, oh, this is timeout, or there's an error. I'm going to handle those errors. If it is successful, then I finally do send packet 2. So this is quite complicated, obviously. Like send delegate is a very simple 2-action thing, but you have to implement all these things. It's quite cumbersome. And this doesn't even mention that we need to register the interchain account first. Now we have assumed you already have an interchain account. But if you don't already have an interchain account, well, they need 3 packets, right? Register, transfer, delegate. Your callback chain will be longer and longer. So this is a lot of complexity for programmers to program. Okay. That's the second problem. The third problem is this pattern I just mentioned is actually literally impossible. Why it is impossible? Because ICS-20 doesn't give you a callback. The token transfer protocol ICS-20 is programmed in such a way that it doesn't inform the sender of the outcome of the packet. So you don't actually receive a promise that you can chain actions afterward. This literally doesn't work. We have seen a few attempts to fix this. For example, Newcom made a fork of the ICS-20 module to add the callback capability. Osmosis created a new module called IPC hooks that just add this thing. So if you're on Neutron or Osmosis, you can probably use their thing, but if you're building on any other chain, you're outside. Problem number 4, there is no atomicity between packets. What do we mean by atomicity? If you have an action that consists of multiple steps, atomicity means if the whole action only succeeds if every and all steps succeed. If any single one of those steps fails, the entire action fails. So this is what atomicity means. And this is a desirable property. Why is it a desirable property? Let's assume we're doing an action that isn't atomic. And assume it has 3 steps, right? And let's say the step 1 fails, right? Now you're left with a state of step 1 failed, but steps 2 and 3 have not been done. So you need to program your contract or application to pick up from that middle state and carry on from that state. Well, what if the first 2 steps succeeds, but step 3 fails? Well, you need to also program your application to pick up from that state. So if you have n states, you have to program all the logics to pick up any of those failed states, right? In our stride osmosis example, let's say, what if we make a typo in a validated address we want to delegate to? Well, in that case, our token transfer succeeds, but delegation fails. But because our actions are not atomic, the token transfer is not reverted. Our tokens are still on osmosis. In this case, you need to program logics either to retrieve those tokens or retry a delegation. So more extra work. Okay, so the previous 4 are major problems. The next 4 are minor problems. They are not life or death situation, but still annoying. Number 1, ICS-20 only allows you to send 1 token per packet. So let's still look at Stride. Right? Stride pays their staking rewards in 10 different tokens. What if I want to build a liquid staking derivative for a Stride? I want to reinvest the other 9. Well, I gotta send nine packets just to send each one of them to osmosis, swap it, and send it back. How many packets is that? How many words that is for repairs? Right? I think it's quite annoying. Problem number 6. ICS-20 allows multiple channels between the same two chains. And the main drawback for this is user confusion. For example, here I'm looking at the min scan. This is between osmosis and Cosmos Hub, and you can see there are 53 channels between these two chains. Only one of them is considered canonical, right? Which is the green one over there. If I'm a confused user, I send my tokens through one of the other channels. Well, the fortunate case, the channel is open, my token is delivered on osmosis, but it is not supported by the application. In the worst case, the channel is not active, maybe the lifetime has expired, then my token gets stuck. And I have to do a governance proposal to revive that channel and get my token refunded. And I have heard numerous cases of this. I think this doesn't really make much sense to allow multiple channels between the same two chains. Right? It doesn't make much sense. The last two problems are with interchain accounts. The first one is it doesn't have AwesomWasm bindings. So if you want to work with interchain account from your AwesomWasm contract, you need to compile those protobuf files. Right? They use the protobuf encoding, which if you have worked with protobuf in Rust, you will agree with me, it's not a very pleasant experience. So ideally, we want a language agnostic encoding such as JSON, right? Okay, the very last problem, ICS-999 uses ordered channel. We mentioned this previously. It has the advantage that packets sent within the same channel can be ordered, but it often comes with a major drawback, which is its fragility. By fragility, I mean, if a single packet in your ICS-27 channel times out, meaning it is not delivered within a certain amount of time, the entire channel is closed. This behavior is necessary to enforce encoding, but let's just say how many applications really needs that high level of ordering. Probably not. If you really want, if you have several actions, you want them ordered, just put them in the same package, right? Then they will be down in order. We don't really need that strict ordering between many packets. So that is my opinion. Alright, so that is the 8 drawbacks of existing protocols. And now I'm going to show you that my protocol ICS-999 solves every single one of them. So here's a table comparing existing protocols and ICS-999. The existing protocols, these two packets for the send and delegation task. ICS-999 only a single packet. The existing protocols impossible to enforce order between channels. ICS-999 no need because we only have one channel. Existing protocols not atomic. ICS-999 is atomic. Existing protocols does not provide callback to the sender. ICS-999 does provide callback to the sender. Existing protocols only one token per packet. ICS-999 send as many tokens as you want in a single packet. Existing protocols allows multiple channels between the same two chains. ICS-999 only one channel allowed, no user confusion. Existing protocols does not have CW bindings, only has uses protobuf encoding. ICS-999 is entirely built in AwesomWasm. You can interact with it just the same way as executing another contract, and it uses JSON, which has native Rust support. Existing protocols uses ordered channel easily drop dead. ICS-999 uses an unordered channel, which is perpetual, meaning it never gets closed. Yeah, so I hope you agree with me that it's yeah, so how is ICS-999 able to achieve this? Well, to explain that, I'm going to show you the packet data structure. So on the top left, you see the packet data structure. It just contains 3 things. The sender address, obviously. The actions that is the core thing of the entire protocol. We will talk about that in a second. And the third thing is traces. This is just an auxiliary data used for token transfer. If you populate it for you automatically by the contract, you don't need to worry about it. Okay, so let's look at actions. Actions is a Rust enum. It has a few variants. For example, you can do register an interchain account. In which case you can provide a salt. It uses instantiates tool to register that account, so you can predict the contract address ahead of time. You can make a token transfer where you specify the enum and amount. Recipient is optional. If you don't provide it, it defaults to your interchain account. You can execute any Cosmos message, or you can make a query, right? And you can pack as many actions you want into your packet, as long as it fits in the packet data size limit, which I think is 1 megabyte, and the execution gas limit, obviously. So how do you actually do this? Well, on the bottom right, we have the execute message of the ICS-999 contract. It has one method, which is act. So you just call act, you tell it which connection ID you want this packet to go through, and a list of actions. That's it. So really simple to use. Back to the stride osmosis example. How do we do this using ICS-999? Well, on the right-hand side, that is your execute message. We start by registering an account. And step number 2, we make a transfer to that account. We don't specify a recipient so that it defaults to our account. Then step number 3, we execute a statement delegate message. That's it. So it's very simple. And let's also talk about callbacks. This is something that ICS-20 doesn't give you, but ICS-999 does give you. So on the top left, you see the acknowledgement data structure. The packet can have 3 possible outcomes. One is timeout, meaning the packet is not delivered to the recipient chain at all. Outcome number 2, it has an error. And outcome number 3, success. So in case of success, we will give you a vector of action results. So for each action, there is a result. For register account action, we will give you back the account address that was just registered. For transfer, we're going to give you the IBC denom on the recipient chain and a number of other things which I will not go into too much detail. For execute, we will give you the response data that was returned. For query, obviously, we're going to give you the query response. So on the bottom right, your sender contract can optionally implement these 2 methods. So if your packet times out, ICS-999 will call the packet timeout method and tell you what is the sequence number of the packet. If the packet has been delivered, we will call the packet act method to tell you whether it succeeds, or maybe if it fails, we will tell you the error message. So let's make a brief summary. What is the entire packet lifecycle if you use ICS-999? So on the top left, we have a sender contract, which in our case is the stride liquid staking protocol, and we have the ICS-999 core contract. So the first step is to call the act method. The ICS-999 contract, on receiving your list of actions, will compose a packet and send that to the 999 contract on osmosis. That contract will then execute your 3 actions one by one: register account, make the token transfer, and make the delegation to the validator. They'll then collect the results for each action, return to stride, and it will give the sender contract a callback, informing it of the outcome of the packet. So that is the entire website. It is clear? So I'm an honest person, so I'm not going to say ICS-999 is all good, no bad. We do have a few drawbacks, so let's discuss each one of them. The first drawback is that the token denom is not compatible with ICS-20 denom. So if you send, like you have stride token, right? You send stride token to osmosis via ICS-20, that's going to give you denom on osmosis. If you send the same token but through ICS-999, that is going to give you a different denom on osmosis, and they're not compatible. So you gotta pick one as your canonical representation. Either ICS-20 or 999 cannot be both. If you already have a token, then you probably need to migrate. Right? So that's kind of a tedious process. Drawback number 2 is the token creation fee. So ICS-999 uses the token factory module to register new IBC denoms. However, for most chains that have token factory, they have a non-zero denom creation fee. So that means the very first time you send a token from one chain to another, you need to pay a fee on the recipient chain for creating that denom. You don't have to pay the second or third time, you just need to pay the first time. So like smart contracts are second-class citizens in Cosmos SDK. So ICS-20 is implemented as a module, and modules can mint new denoms without charge, but contracts need to go through that token factory thing, which optionally can charge you. And it doesn't make any sense. So the idea for creating that denom fee was to prevent spamming. So like, what if a malicious contract just creates hundreds of thousands of useless denominations on every chain, right? That's the idea, but it doesn't really help because you can already create like spam using ICS-20. You just create a solo machine IBC client and you just spawn numerous tokens. You can do that with ICS-20. So having that fee doesn't prevent spamming, but obviously a lot of chain developers don't get that. So yeah, so they all have a fee, right? For osmosis, fortunately, I passed the governance proposal, so after we have the V16 upgrade later this week, the fee will be 0, but there are still a number of other chains, Stargaze, Neutron, Juno, Terra2, Sage, Injective, Fujira, still have non-zero fees. So I'm calling on the communities and developers of these chains, please set your fee to 0. It does not only kill ICS-999, it also kills composability of every other contract. If you want to know why I read my proposal, there is a GitHub issue written by Ethan Fry that explains exactly why this fee is bad. So please give it a read. Drawback number 3, there is no support for multi-hop transfers. For ICS-20, there is a thing called packet forward middleware, which allows you to send token with one click across multiple chains. It will be equipped on Noble and another chain, a few other chains. This is not possible to implement in AwesomWasm because AwesomWasm doesn't give contracts very low-level control on how to accept packets, write acknowledgement, etc. So packet forward middleware uses some low-level tricks to implement it that are not available to AwesomWasm. So as of now, we don't have multi-hop transfers, and I think this is really the biggest drawback of 999. I think in the future, I think the world of interchain will emerge in the world of interchain, there will emerge a hub and spoke model, but it will not be a single hub like Polkadot, it will be a multi-hub. Like there may be a hub for all the chains, all the DeFi chains. There may be a hub for all the gaming chains. There may be a hub for all the Atom economic zone chains. There may be a hub serving the Asian community, for example. In which case, your transfer will need to hop across those hubs to be delivered to its final destination. So I do really think packet forwarding and middle hop is of very high importance, but we are unable to support this in AwesomWasm at the moment. So if we do support it, this is the new packet data structure. We're just going to have a new field of hops, and we provide a list of IBC endpoints. But it'll be pretty easy, but not possible for now. I think it will come in AwesomWasm Week 2, because 999 happens to be not the only protocol needing this feature. I think Noise Network may need it. So there's demand. I think this feature will come in V2. If it does, we can implement multi-hop. Drawback number 4, error messages are redacted. So Simon talked about this in his earlier keynote. So I told you that if the package fails to execute, we will return you the error string in the acknowledgement. Well, I lied. You will not get the actual string. You will only get this thing called read code space wasm code 5 execute wasm contract failed. This is the you will get this string every time. The reason is that the error strings of Cosmos SDK is not guaranteed to be deterministic. So they are redacted. We only tell you, oh, the contract failed, but we cannot tell you why it failed. So hopefully this gets fixed in AwesomWasm v2. Yeah. The final drawback, there's no relayer fee support. Relayer fee is just another very, very important thing besides multi-hop. We cannot expect IBC to be free forever. So I can perhaps implement ICS-999, but 29 doesn't support multi-hop, so I don't really see any point in copying it. So if you do a multi-hop transfer using 29, only the first hop is paid. The second and third hops are not paid. So yeah, we need to come up with a new design that supports multi-hop. And I don't have a good solution yet. It is something we as a community needs to research. All right, so those are for the drawbacks. Let's also talk a bit about future development. The first idea I want to implement in the future is to put coins directly in the acknowledgement. Let's think about this use case. They are stride, they have some state pattern. We want to swap that to stride token on osmosis, send it back, and restake it, right? So currently, you can do the first two steps, transfer and swap, in one packet, but sending the this is supposed to be stride, not osmo. Well, sending the stride token back requires a separate packet. So the idea is we can just put those tokens directly inside the acknowledgement, as you see on top left. That can reduce the whole thing to one single packet. I think many developers will find this useful. And another idea is programmable interchain account. So in ICS-27, interchain account is just a normal account. It's not a contract. It is not programmable. Currently in 999, the interchain account is a static contract. Static meaning all the interchain accounts share the same contract. We don't allow you to program anything in it. But for more complex use cases, this becomes a bit limiting. So the idea is, since the interchain account is a contract, we can allow the user to just provide their own, right? So you can program any logic in your interchain account and interface it with 999. So that is the idea. So that's pretty much for it. I would like to call on my fellow developers. If you plan to release a new token, please consider use 999. If you are build wallet apps or web UIs, please consider integrating 999. And that's all. That's all I have for this hack talk. But since we are at a AwesomWasm conference, I'm going to shill AwesomWasm. And I'm going to do this by just looking at the code base. On top left, you have the ICS-999 code base. The entire thing is written within 2,000 lines of code. But if you look at our competitors on the top right, ICS-20, 11,000 lines of code, interchain account, 15,000 lines of code, interchain queries, 12,000 lines of code, IBC hooks, 800. That adds up to 40,000. And I am able to implement the very same thing with even better functionality with 20x less code. I think this is proof that AwesomWasm is the superior framework for building IBC application layer protocols. So if you are also building IBC stuff, use AwesomWasm. That's all. Thank you.